Welcome class. Today we're going to work on an exploration on finding the number e. E is one of those numbers in math that is similar to pi. It's called a transcendental number, and it's a number that basically is a non-repeating and non-terminating decimal. Its approximate value we'll find is 2.718. Remember that number? It's going to come up later in this lesson. To find e, we're going to go back to a concept that we learned about last chapter on continuous compounding. If you recall continuous compounding, it's using the formula y equals p times 1 plus r over n to the nt power, where p is the amount of money that you put into the bank, r is the interest rate converted to a decimal, n is the number of times that you compound the money per year, so 12 for monthly, 52 for weekly, and so on. T is the number of years that you will invest the money, and y, what the formula equals, is the amount of money that you earn over that time period. For this exploration, to find the number e, we're going to keep it simple, and we're going to invest $1, so that's going to be our p, at 100%, that'll be our r, for 1 year. That will be time. So if p is 1 and r is 1, because remember, 100% as a decimal is 1. So if p is 1 and r is 1 and t is 1 for 1 year, the formula that we're going to be using is y equals 1 plus 1 over n to the n power. So we're going to explore what happens as we change n to various compounding periods. We'll do once per year, twice per year, 4 times per year, and so on. To do that, we'll use this chart on your handout. And what we're going to do is, in our calculator, you're going to go to y equals, and you're going to enter 1 plus 1 over x to the x power. Then we're going to use a table to find out what happens to the amount of money over time if you compound it for 1 time per year, twice per year, 4 times per year, 12, and so on. We're going to see what happens to the total amount of money that you have. So let's go to y equals on the calculator and enter this function. Now that you have the function entered, I want you to go to table setup and make sure that you have it on ask. So we're going to be able to input any independent variable and it'll calculate the y. If you go to second table and in your x column put in 1, 2, 4, 12, and so on, you can see what the y values are that are returned. So go ahead and take a moment to plug in those x values and see what happens to the amount of money after 1 year. I copied those values into this page on the in the Smart Notebook, and you can see here that if you only compound the money once per year, you would end up with $2 at the end of that year. After 2 times per year for 1 year, you would end up with $2.25. If you compounded the money 4 times within 1 year, you would end up with $2.44. So as you can see, when you increase the number of compounding periods in a year, your total amount of money does rise. However, I want you to notice what happens toward the bottom of this chart. You can see that in the formula 1 plus 1 over n to the nth power, as this n gets larger and larger, as this n and this n, remember they're going to be the same number, as they increase, the amount of money goes up, but it tends to slow down, and it reaches a limit. And that limit is what we know as E, 2.718. So that's how we find the value of E in math. The conclusion is, and this is a calculus concept that I'm going to throw at you here, what we have here is known as 1 plus 1 over n to the nth power. In this formula, we have something called a limit. We've we've talked about the concept of a limit before, but we've never seen this notation. LIM basically means that we're finding the limit of this function as the n, as the variable n, gets closer and closer to infinity, which means that n is going to get larger and larger without bound. And as that happens, it tapers off at around 2.718. And that value is called E. Just like you know 3.14 is the approximate value of pi, 2.718 is the approximate value of E. That concludes our study of how E is found in math.